Hello boys and girls, here we are on a Friday afternoon. I'm going to do a little video for you. I have here a copy of the lab data, which is underneath my board right here. And I'm going to write the equation for box number 23. Box number 23, you'll notice, has sodium phosphate and barium chloride. So the instruction number 1 on a lab handout's over here. Let me drag it in real quick. Lab handout says, in number 1, you'll see, for each mixture that resulted in a precipitate, write the possible chemical reaction or equation for the reaction. Be sure to write all formulas correctly and then balance the equation. A precipitate, this word right here, means to fall out. So in your life, you know that precipitation means rain falling out of the sky or snow falling out of the sky. In chemistry, precipitate means a solid falling out of a liquid. So if these solutions turned cloudy when you mix them today, they made a precipitate. All right, so basically there are 3 steps to what we're going to do. We're going to do combinations, formulas, and balance. So we're going to do combinations first, then we're going to write chemical formulas, and then we're going to balance the equation. So as you look at the chemical formulas that I wrote down, sodium phosphate and barium chloride, you will notice that there are 4 underlines. I underlined a cation, an anion, a cation, and an anion. So you have to kind of think of these things as if you've got a boy and a girl. So the cation's like a boy, and the anion's like a girl, and then the cation's like a boy, and the anion's like a girl. They went to homecoming together, and decided by the end of the night that they really like each other's dates better than their own, and so they changed partners. So this ion goes where the barium was and combines with the chlorine, and the phosphate goes with the barium. So your new combinations would be barium, and what did I say? It would go with what? The PO4, and the sodium would go with the chlorine. All right, now you may notice, hopefully you do notice, that on this side there are 3 sodium atoms, and I did not carry that 3 to the other side. And you will notice that there's a 4 here, and I carried that 4 over. You'll notice that there's a 2 here, and I did not carry that 2 to the other side. So why is that? And here are the instructions for that. It says in bold print, subscripts that are part of a polyatomic ion carry over to the other side of the equation, and other subscripts do not carry over. So you may remember that we have a class web page. So if we go here and take a quick look at the periodic table, at the bottom of the periodic table is a list of polyatomic ions. Right down here, common polyatomic ions. So if you go back to the formulas that we have here, you'll notice that PO4 is a polyatomic ion. Here it is. PO4 is right over here. It's called phosphate, and that 4 is part of the phosphate. So it gets carried over to the other side. The 3 here and the 2 here are not part of the phosphate, are not part of polyatomic ions, so they don't get carried over. All right, so now we've done step 1. We have written our combinations. So see, step 1, combos, check, done. Now we need to write formulas. To write chemical formulas, you have to use charges. So I'm going to put a note here. Writing formulas, you will use charges and subscripts. The charges are the little numbers that are on a periodic table, and a subscript, of course, is a little number down below, like this one, subscript, written below. Script means written, sub means below. All right, so looking at the periodic table, if you look at barium, you'll find that its charge is positive 2. Now I would expect you to know that because it says positive 2 right there. And I also expect you to know it because it has 2 valence electrons, and we should know that atoms with 2 valence electrons will tend to lose them and have a positive 2 charge. You can see down here that phosphate is -3. It's a little hard to see on the size of my periodic table here. Look at this. I'm such a whiz with these computers. All right, so see that PO4 is -3. All right, so we'll take that back down. All right, now back over to here. So we know that barium is +2. We just saw that. and phosphate's minus 3. Sodium is plus 1, chlorine's minus 1, and once again, sodium has 1 valence electron. I expect you to know that it loses that, or you just look at the periodic table and it says plus 1. Chlorine is negative 1, 7 valence electrons, so it's going to gain 1, or you look at the periodic table and it says negative 1. Take time to do that if you don't believe me. All right, now barium plus 2, phosphate minus 3, that's a problem because the positive charge has to equal the negative charge. Because what this positive charge means is that you've lost 2 electrons, and this is saying that phosphate needs to gain 3 electrons. Lose 2, gain 3, it's not the same. They've got to be the same. So how do you make them the same? Well, you need to look for a common multiple. Now I'm guessing that you've heard of common multiple before, but just in case you haven't, you're looking for the smallest number that 2 and 3 will both go into evenly. And that number, of course, would be 6. So 2 goes into 6 3 times. So ultimately, we're going to need 3 atoms of barium. So 3 atoms of barium. And then the phosphate needs to go into 6. 3 goes into 6 twice, so you'd have 2 of those. Notice I put these parentheses in to show us that the polyatomic ion is one entity, one thing. All right, and over here, this is plus 1, minus 1. So again, there's no trouble with that one. It's even already. We don't have to do anything else. So now we've done number 2, write the formulas. Number 3, we have to balance. Okay, to balance the equation, you use coefficients. Coefficients are in front of the formulas. Not middle. So I'm going to put underlines at the possible locations for coefficients. 1 is there, you could have 1 here, you could have 1 there, you could have 1 here, and that is it. You can't have them anywhere else. Not in the middle. Not in the middle. It is illegal to put it at a coefficient in here, or in here, or in here. Can't be done, because that changes formulas, and once the formulas are written correctly, they can't be changed. All right, so here we go. How many atoms of barium do you see here? I see 3 atoms. So over here I only see 1 atom. So that would mean I need to put a 3 in front of the barium chloride. So what that means is I really have 3 barium chlorides. I have a BaCl2 and another BaCl2 and another BaCl2. Or 3 times 2 gives me 6 chlorine atoms. So on this side I only see 1 chlorine atom. So what would I put in front? How about a 6? That, of course, means I've got 6 NaCl. So NaCl, 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 NaCl. You getting the idea? I'm getting tired of writing NaCl, NaCl, NaCl. 1, 2, 3, 4, 5, 6. There's 6 of them. So over here I only have 3 of them. So what would I put in front? To make them even, I'd put a 2. Of course, my next question is going to be, what effect does that have on the PO4s? All right, so you look at this. This PO4 is one entity. So how many PO4s are there? 2, because there's only 1 PO4 in the equation. It is very common. I'm sure you guys will not make this mistake, but many students in the past have told me repeatedly there are 8 PO4s here. There are not 8. There are 2, because there was only 1 PO4, and there's a 2 in front of the formula. So now that equation's balanced. I've got 6 sodiums, 6 sodiums, 2 PO4s, oh look, 2 PO4s, 3 BAs right here, and 3 BAs right here. And 3 times 2 makes 6 CLs, and 6 times 1 is 6 CLs, and that is the complete equation for that reaction. So I'm expecting these equations to be written under the data table in your lab book in order. So this was equation number 23 or something like that. I forgot what number was that. I don't remember. I think it was 23. Let's get this back out of here so I can see. Here's the data. Yeah, it's box 23. Okay, this is taking a little longer than I thought it might, so I'm going to stop this video and make one more. maybe 2 more, probably 1 more. So I don't get so long to process it in a few minutes when I try to upload it to YouTube.